Hello and welcome to my channel. I'm Derek, and in this video I'm going to show you how I created this forged carbon fiber foot peg bracket to replace this ugly cast aluminum stock piece. I hope you like this video. Stay tuned to the end to see me put it on and do some tests with it. With the unit right from the bike, the first thing that I wanted to do was replace the foot pegs. These are really big and clunky, and actually on the other side they were ripped off and just ugly. I needed to replace them anyway. So I found the Cognito Moto foot peg brackets that are folding, which I have on the new piece here, that I really like. So when I got those, I did mount them on here, and I thought that it just didn't look right. They were too modern for the look of this old piece. Granted, I could have sanded this down, cleaned it up, and painted it or powder coated it to make it look a lot more modern, but it still just didn't match the bike. And when I decided to do forged carbon fiber for the subframe, I thought, well, what would make it look really nice is if I did the foot peg bracket out of forged carbon fiber as well. Originally, I was thinking of making it billet aluminum, same with the subframe, but the issue just comes down to cost and complexity. So to start off with, I had to reverse engineer the stock piece, and there's so many ways to do this, and a lot of people have different techniques for how they do this. In this case, what worked best for me was to take the flat face of this foot peg bracket, lay it down on a large sheet of paper, trace it with a pencil, go into the holes and mark where the holes are in relation, and then take that sheet of paper, put a ruler on it, and put it in a scanner and scan it. And then once it was scanned, I was able to open that up into SolidWorks, or that's my preferred CAD package. And then I can scale the image based on the ruler that I put in the image. And then from that, I can design the part around. So what I did is I would 3D print small little pieces that would make sure that I could get the whole pattern correct. Once I got the whole pattern correct, I replicated the part in 3D print. I did a few things a little bit differently on the back side. This is just a cast part. You can see it does have some supporting ribs and looks a little bit different. To make it a little bit easier for me to do the forged carbon fiber, I made it a lot more simplified on the inside, but I kept some very strong ribs for where I knew the parts were going to mount. So from there, it just came down to making the mold. So what I'll do is I'll take you through designing the mold, the actual cleanup process, the 3D prints, forging the parts, and then we'll touch base at the very end and we'll get it on the bike, and I'll talk you through some of the other things. So I hope you enjoyed this video. Thank you. Creating the mold for any sort of part for forged carbon fiber is really complex, but when you get a part that's actually quite large like this, it becomes even more complex due to some limitations, especially on my side with my 3D printer. So I can't actually print this whole piece as one because it's too large, so I do need to split it up. But just in general, creating a mold is actually quite difficult for a number of reasons, right? You have to identify the direction that you're going to be pulling the part out. You need to make sure that you have available draft in the part so that when you do go to split it up, it can actually be pulled apart. You have to take liberties for how you're going to actually get the components off. And in some cases, you even want to add in some ejector pins. So in this design, I added in a lot of these flanges around the outside of the part, which actually helped it really easily split from the mold. So you want to make sure that you chamfer all of those edges and allow yourself a way to drive like a wedge in there so that you can split those up. In my previous design, I did it a little bit differently, and I actually found that this was the easiest section, or easiest way to do it, is by creating these flanges on the outside. But then what you'll notice is in these sections here, these green pieces, there were some parts of the actual foot peg that sat a little bit lower than the top side. So these needed to essentially be inserted before the piston starts going in. So you have to take note of, okay, how much material gets put in every place. So you kind of want to have like a uniform thickness all the way throughout, and you want that top surface that your piston to kind of be flat. That way when you're pressing and you're packing it in, it's all packing kind of consistently. But in my case, I had some parts of the actual foot peg that lived a little bit below where that top surface is. So those green pieces actually went in beforehand, before the piston went in, to drive it home, but also it kind of held those down in that location. When we actually go to do the forging, you'll see what I mean. But the biggest challenge here is essentially just making sure that everything can pull apart. You've got radiuses where you need them. You've got chamfers where they need to be, so putting in all the chamfers now, and then just making parts that actually bolt together. So I like to download fasteners from McMaster-Carr, the ones that I have purchased or the ones that I'm going to purchase, and make sure they fit within the model, have the correct amount of engagement in the nuts. But the one thing that I learned while doing this is having all of these bolts accessible from the top side is really great when it comes to putting it together and taking it apart. But they also got filled with epoxy, and it actually made it quite a bit more complex. What you'll see is I am creating a BOM for all of my fasteners so I can go buy them. And then in this case, right now, I'm creating essentially a base to it that holds it at an angle. Because this part is angled on the top side, I needed to fill up one section of it a little bit higher than the other. So I made these pieces to kind of make it level so that I knew the top side could be level. So once everything was printed out of PETG, I actually used like, I want to say 5 or 6 wall loops and only 20% infill. I know other places recommend that you should use like 75% infill, but I didn't necessarily go that route. 20 seemed to work fine for me. I didn't ever have any blowouts during the molding process. But during the printing, you know, the faces aren't necessarily perfectly flat, so you need to sand them so that you create an airtight barrier. I did, in this case, put some tape in between them. I thought that tape might be a good way to seal up any sort of cracks that you might have. And I tried to do it everywhere, but the tape wasn't thick enough, and it ended up creating an absolute mess. But, you know, test fitting the part and making sure that you can get the piston in before you do anything is really key. So making sure all your bolts go together and everything fits appropriately is really key before you start doing anything. And then ultimately, before you do any sort of forging, you want to make sure that it is watertight. So if it's not watertight, epoxy is just going to leak out of it, and then you're basically going to ruin everything that you're planning on. So in this case, you'll notice that everything was not airtight, and I've got water leaking out. So if you can't get it watertight, one way to fix that is some silicone. So my wife and I sat down and we put some silicone every place where the parts would meet, and we basically siliconed the entire mold together. Ideally, you want to spray release wax on all these parts before you put them together, but in this case, because we're putting silicone on it, you need to put it all together with the silicone before you can do the release wax. It does make it a little bit difficult when you're spraying the release wax on there before the molding process, just because it's a little bit harder to get in those nooks and crannies, but with the silicone in place, you definitely know that you're going to get a nice watertight seal everywhere. So I used just clear silicone. You can find it anywhere. It had some pretty quick cure times. And then once everything was bolted together, you need to make sure that you go in there and try to clean up as best possible. It is really hard to get down into that mold because some of those areas are pretty tight. So we use like Q-tips and screwdrivers and whatnot to get in there to try and clean out any sort of the areas as possible. And then I also used some like IPA wipes to clean everything up. So the inside looks really good from all the silicone. The outside definitely has some spill out, but I'm not too worried about that. Just want to make sure that it is nice and watertight. So now I'm going through cleaning up. You notice these little blocks I put on in the past project I did. I made the top surface much higher, and you had kind of like a flange all the way over. so that when you press it in, you know when to stop. But that wastes a ton of material because you essentially have to add that entire top side up. So those little blocks allow me to know when to stop with the compression without spending so much time or spending so much material. So in this, to make forged carbon fiber strong, you need to have long strands of it. You don't have to, but it does increase the strength. So in this case, I've got a bunch of 100-foot sections that I was using to wrap up so that I can have long strands put in. So in this project, I did 600 feet of continuous fibers or continuous strands, but they're broken up into 100-foot sections. You can kind of see them laying there, and then we will put them in. So doing all the math to figure out exactly how many you need versus your weight. So there's a little bit of math involved, and you can see my previous video to see exactly what math you need to do, or check out one of the easy composites videos. Packing the mold is the most challenging. You can see we're starting to pack in some of the large continuous fibers, but essentially you want to make sure that you wet down the mold and then just start packing and wetting as you go. It doesn't hurt to have extra epoxy, because any extra epoxy you have will just essentially get pushed out during the forging process. When you start pushing that piston in, you'll just get all the resin come out. You just want to make sure that you are wetting down everything really good. If it's not wetted, it's obviously not going to glue itself together. So this is the most tedious and time-consuming process. You can see I'm starting to put in some of those little corner sections. Once you've packed it in enough, you can kind of put those in, drive them in, and then continue around. So my wife and I are going through and essentially just putting more carbon in, laying it with more epoxy. You can see we just put in a nice long section, trying to add that strength in, and it's just a really time-consuming process. It is really messy, so you'll need to make sure that you set up the area well. We like to use like parchment paper because the epoxy doesn't go through it. If you just set up like some cardboard paper, paper towels, the epoxy can seep through and then get anything below. So just make sure that you have a nice clean area. You want to make sure that in your mold design you provide yourself enough room above so that you can start driving that piston home. In this case, I didn't make it quite tall enough, so it was a little difficult, but once you start getting the clamps on there, you'll start pushing them down. In hindsight, I wish I had a little bit more clamps, but 4 was good enough for here. One thing that ended up happening is the bigger side of the mold, actually we put too much epoxy in on that side, so I couldn't fully seat the one side, so it actually has more material on the one side than I planned. But ultimately it doesn't seem to be an issue. It is something to note going forward, that I need to make sure that I am very even when applying the epoxy, or applying the resin and the epoxy. I kind of thought that that side would take so much more, so it needed to have a little bit extra during the compression, but it didn't. So you can see based on those flanges I had, it was actually pretty easy to remove those side pieces. And then the ejector pins that I designed in there were quite difficult to get out, and ultimately ended up going and taking this into work and using an arbor press on those ejector pins to help get those out. So when you do this process and you push all of that epoxy in, a bunch of the resin comes out, and essentially you are creating a vacuum in there. So the parts not only are in there just because they're a nice tight fit, they're literally vacuumed to one another. So some of the other things I did was like drill some holes through the mounting locations that I knew I needed, and that actually helped get it out. But then once you pull the part out, there's a ton of flashing on it, so you'll need to go ahead and clean that up. If you do any sanding on it or anything like that, you want to make sure that you are wearing a respirator. You don't want to be breathing in any of that carbon dust. It's not good for you. I like this full face mask because it covers your eyes as well. The fine particulate dust that this creates is pretty crazy, so you don't want to breathe it in, and you definitely don't want it in your eyes. But when you pull it out of the mold, it's The finish on it is not great because it looks exactly like the 3D printed part, so it does take a fair bit of cleaning up. So I cleaned up all the flashing. You can see it still looks rough like the 3D printed part. And then I'm gonna go ahead and start sanding. And then once it's all sanded down, you'll notice that the fibers look a lot more prominent than they were before. So at first it just looks like you're dulling the part, but you need to kind of get that top layer off. And once you kind of clean it up, you'll notice that those fibers really start to shine. I hope you really enjoyed the time lapse. There were a few things that I didn't show that I thought I would need to point out. Taking apart the mold was actually quite difficult, and what I ended up doing is I had some ejector pins. I didn't necessarily highlight that in any of the videos, but you'll notice in some of the ones where we were looking at the mold specifically, there were some metal dowel pins. Those are technically ejector pins. What I ended up doing was putting some pins in there and going to an arbor press and actually pressing the mold apart. That was the only way to get the parts apart. So if you are designing some molds like these in the future, make sure that you add in some pins that you can use to press the part out. They were just dowel pins, they weren't anything specific, and I did it on the back side so that you wouldn't necessarily really see them, but they became so flush with the part that it didn't necessarily matter, and I'll actually do it on the front side and the back side with parts going forward just to make it easier to split up. The other thing I didn't show was drilling the holes for the mounting. So I didn't actually include the holes in the mold, but what you'll notice if you go back and look, there were some little tiny posts that I had in there, and that just gives me the hole location. From there, I needed to drill out the holes. But what you'll notice is, even on this part, it might be hard to tell, but the holes are not perpendicular with this front face. So if I were to lay it down like this and try to drill through, they would always end up a little bit crooked. So what I ended up doing was I 3D printed this template essentially that would hold the part level. So you can see it's a little bit thicker over here than it is over here. So you put the part in, I would have the little posts on the back side of the part, and then from there I could use a drill press to go through and drill through the part. And that ended up working really, really well. And surprisingly, it fits perfect on the bike. So let's go over to the bike and let's get it on there. When I did my initial test fit, I thought for sure this is not going to fit. I know that the 3D printed one that I had some pretty large holes in there just to fit over the studs that are in here. So I thought there's no way that this one is going to fit because there were just some challenges that I had with the mold. It was a little bit thicker on one side. It didn't fit perfectly on the template, but surprisingly, somehow it fits absolutely perfect on the bike. The holes that I drilled are literally like the exact size of the bolts that go in and the studs. So somehow it fits absolutely perfect. But I guess, as some would say, I designed it to fit. So let's get it on the bike and let's take a look at it. All right, so there we go. It's on the bike. It looks really awesome. Now, the next thing that we need to do is test out the strength. So one thing that I would do is I'll stand up on this back peg and make sure that it doesn't break. All right, let's test the strength of this guy. So fully supports my weight. Now, if I put all of it up on this rear peg, I'm gonna try and balance as best I can. As you can see, all of my weight is on the back of this. We have no issues whatsoever. Super, super strong. So, not worried about the strength here. Let's take a little bit more of a look. So this is what the foot peg looks like on the bike. You can see it still needs to be finished up. I still need to sand some areas, and it's got some holes in here. But overall, once it gets the final layer of epoxy on, it's gonna look really, really nice. So with that being said, what do you guys think of how it looks on the bike. Do you think I should have just modified or painted the stock piece, or do you think I should, or do you think it was a really cool idea to do this forged carbon fiber? I'd really love to hear what you guys think. All right, do you think I should have just painted the stock piece, or do you think that this forged carbon fiber is really cool? Now, this look that you're seeing here is going to be the same on the subframe. What you're seeing here isn't the actual design, but do you think it's going to look really cool? I'm super excited to try it. I'm going to do the other side next before I tackle the subframe, because this whole piece essentially is going to be one forged carbon fiber piece, so it's going to be really difficult and take a lot of time. So I'm going to try and learn as much as I can on the other side before tackling the subframe. But what do you think? Do you like it? So thanks for checking out this video, and I hope to see you in the next one.